Have you ever really stopped to think about how engineers make things like the cruise control in your car or even the thermostat in your house work so perfectly? It's all about something called control system design. And today, we're going to look at a tool that just completely flipped the script on how it's done.
So let's get right into it. For the longest time, designing one of these controllers was this super intense, slow, and frankly painful process. It was all about trial and error, based on a mountain of complex math that had to be done by hand.
I want you to just imagine this for a second. You have to redraw a really complex graph, like a root locus or a Bode plot, from scratch every single time. You just wanted to tweak one tiny little thing. That was the reality. It was slow, it was tedious, and it absolutely killed any chance to get creative and just try things out.
But then, MATLAB came along with SISOTOOL. Now that stands for Single Input, Single Output, and what it is a graphical user interface, a GUI, that takes that whole painful manual process and makes it interactive, visual, and best of all, immediate. So when you fire up SISOTOOL, this is what you see. It's like your design cockpit. Over on the left, you've got your command center, the Control and Estimation Tools Manager. That's where you make all your changes. And on the right, you see the results right away on live plots that show you exactly what your system is doing. It's pure cause and effect, right there, side by side.
Okay, so how do we actually get started with this thing? Well, the whole process kicks off with a really simple setup, where you basically just tell the tool what system you're trying to control.
And it really just breaks down into two main things. First, you're going to select your control architecture. Think of it like the blueprint for your design. And then you import the specific mathematical model of the thing you're trying to control.
So this architecture window pops up, and it gives you a bunch of standard blueprints for control loops. You just pick the one that fits what you're trying to do. It sets up how all the important pieces, the controller, the system itself, and the sensors are all going to talk to each other.
And this is where it starts getting really slick. Instead of having to type in a bunch of complicated equations, you can just import your system model, engineers usually call this the plant, and you see it here as G, directly from your MATLAB workspace. Just like that, the unique digital DNA of your machine is loaded right into the tool.
All right, with the setup all done, we get to move into the real heart of the process, the interactive tuning. This right here is where the design truly comes alive, and it's where SISOTOOL absolutely changes everything.
Now, SISOTOOL gives you a couple ways to do this. You could go with automated tuning, where you basically tell the algorithms your goals and let them crunch the numbers for you. But for this explainer, we're going to focus on what I think is the coolest part, graphical tuning. It's this amazing hands-on approach where you directly shape the system's response. With the graphical method, you're not a mathematician anymore. You're more like a sculptor. You can literally just grab these things called poles and zeros on the plot. You can add them, delete them, drag them around. Think of them as the master tuning knobs for your system. Moving them around directly changes how fast the system responds, or if it's stable, or if it overshoots its goal. It's just an incredibly intuitive way to build your controller. But, just being able to move those things around is only half of it. The truly revolutionary part, the feature that makes all that old, painful manual work just disappear, is what happens the moment you move one. And this is the absolute game changer. The second you drag a pole or adjust the gain on one screen, the other plot, the one showing your system's response, updates instantly. You see the effect of your change in real time. That's it. That's the feedback loop that kills all the guesswork. No waiting, no recalculating, just immediate visual feedback.
Okay, so once you've tuned your controller and you're feeling pretty good about the general response, it's time to actually verify the design and, get your finished work out of the tool.
So to make sure everything is perfect, SISOTOOL gives you all these awesome analysis plots. You can pull up a step response, for instance, and check all the key performance numbers, like rise time or settling time or peak response. This is how you prove that your design actually meets all the specs you were aiming for.
And when you've confirmed it's good to go, getting your masterpiece out of the tool is, well, it's about as simple as it gets. You just click File, then Export. This little window pops up, you pick the piece you want to save, in our case, it's our final compensator C, and you're done.
And what's the result? What do you get for all that work? You get a nice, clean transfer function. It's basically the final mathematical recipe for your controller, and is exported right back into the MATLAB workspace. From there, it's ready to be used in a simulation or even put on real hardware. The whole design cycle, complete. So when you just take a step back and look at this whole workflow, you realize the impact here is way bigger than just being faster. It's a fundamental shift in how engineers can think and work. By getting rid of all that manual recalculating and replotting, SISOTOOL completely transforms controller design. It goes from being this slow, repetitive chore to a fast, intuitive, and I'd even say creative process. It lets engineers try out dozens of ideas in just a few minutes, and they start to build this deep, gut-level feel for how systems behave. And that, right there, is how you accelerate innovation.
And that just leaves us with this one big, fascinating question for the future, right? When the barrier to designing a perfect, high-performance control system is this low, when it's this fast and this intuitive, what kind of incredible new machines and systems are engineers going to be able to dream up? The possibilities are really, really exciting to think about.